Okay, welcome to part two of my pre-calculus review. I am working with unit two. This is really the trigonometric unit. So I am on number 4. So determine the quadrant for each. So in this case, sine is going to be positive. So I'm going to start off with writing down all students take calculus. So where is sine positive? Well, sine is positive here and here. But where is cosine negative? Well, cosine is negative in this quadrant, right? It's not negative in the first quadrant because it's positive there, so we're talking about quadrant 2. In here, cosecant, which is another way of saying sine. So where is sine negative? So all students take calc. So where is sine negative? Sine is negative right here in the second or third and fourth quadrant. But where is tangent positive? And that would be quadrant number 3. It doesn't matter if it is the reciprocal of it. We're still wondering if it's going to be positive or negative. And those still kind of traits still come true. So secant, which is really saying cosine. So cosine is less than 0. So where is cosine negative? And cosine is negative both in quadrant 2 and quadrant 3. And then it says, what quadrant is tangent negative of those two? Well, tangent is positive in quadrant 3, so we're talking about quadrant 2. So that would be quadrant 2 again. All right, right here for these, it says determine the exact value from these values. So another way of writing the inverse sine of root 3 over 2 is another way of saying sine of theta is going to be equal to root 3 over 2. So when does sine of theta equal root 3 over 2? And if you know your trig values well enough, that will give us 60 degrees. And then what is cosine of 60 if I end up placing theta? Well, if I end up placing 60 degrees here, so what is cosine of 60? That is going to be 1/2. Tangent, so I would say tangent of theta is equal to 1. And when is the slope going to be equal to 1? That would be 45 degrees. So I would say for sine of 45 degrees is going to give me root 2 over 2. Now this is just a funky way, so the 1 over root 2. So 1 over root 2. I'm going to rationalize that by multiplying root 2 by root 2, both the numerator and the denominator. So I get root 2 over 2. And then it's going to be negative. So where is cosine of theta going to be negative root 2 over 2? Okay, so we're talking about 45 degrees, but since it's negative, we have multiple kind of quadrants to kind of figure it out. So where is cosine negative? Well, cosine's negative in quadrant 2 and quadrant 3. But when we're dealing with these inverse values, we never use quadrant 3. So the one that we will be using is quadrant 2. So that would give us theta is going to be equal to 135 degrees. And then figuring out what is tangent of 135 degrees. Since we're talking about the 45 angles, right, we're talking about right here in terms of that angle measurement. And since the slope is sloping down, it is going to give us -1 for the value. Okay, these ones are a little bit tricky, but they're not as bad as you think. So going back to this idea about sine of theta is equal to y over r. But then what is cosecant of theta? Well, cosecant of theta is r over y. So in this case, what I'm really doing here is this is r and this is y. So I'm going to draw a triangle since they're both positive. So 5 and 8, and theta is going to be right here. Now, what else do I know? Well, I don't know too much else. I could figure out what the x value is, but really what I'm doing here is I'm trying to say, okay, that is theta, so what is sine of theta? Well, sine of theta is really saying the y value over the r value, so it is 8 over 5. And if we kind of have this understanding that sine and cosine, or excuse me, sine and cosecant are reciprocals, then their values are also going to be reciprocals. Okay, over here, sine, so this is y over r. So if I draw my triangle, y is 12, this is 13, and this is actually going to be 5. So it's that 5, 12, 13 triangle again. Still dealing with theta. So tangent of theta, so I replace this value with what this triangle looks like. So now if I say tangent of theta, well, what is tangent in this triangle? That's going to be 12 over 5, and it just ends up working out that way. Okay, next. Now they actually want you to try and figure out the values. So cosine of theta is equal to 1/2. That would be 60 degrees. And where else is cosine positive, that would also be in the third quadrant or the fourth quadrant, right? Because all students take calculus. We're talking about a reference angle of 60 degrees in quadrant 1. That would be 60 degrees. And a um, any measurement with a reference angle of 60 degrees, which is 300 degrees. Now, you technically could say negative 60 degrees, but since we're talking about within this specific restriction, we do need to use 300 degrees. Now, where is tangent undefined? Tangent is undefined at two values, both at this spot, so that would be pi over 2, and 3 pi over 2. Or we could also say 90 degrees and 270 degrees. That is where tangent is considered to be undefined. Next, secant of 2. Now this seems kind of confusing, so I'm going to write this as cosine of theta is equal to the reciprocal of 2, which is 1/2. And actually, that gets us back to letter A. So I'm going to write this as 60 degrees and 300 degrees. Now, working on these types of problems, writing the equation for the given graph. So I'm going to run you through each one of the steps on trying to figure out the values, and then we're going to write our equation. So I think I should have enough room. So I'm going to start off by marking the highest and the lowest point. So the highest here, so I'm going to write that as max, is 4. The lowest point is going to be at -2. And then I'm going to figure out where my period is, so where it repeats itself. So it comes up and it goes back down to its lowest point, and then after that specific section, from lowest point to lowest point, we can see that this distance right here across is going to be how many units long, and that distance is going to be 2 pi. So I'm going to write that as 2 pi. Now I'm going to write my A value, which is known as my amplitude. That is going to be max minus the min that you have to do first and then divide that by 2. So I'm going to write 4 minus -2 divided by 2. So it gives me 6 divided by 2, which gives me 3. Now my B value, which doesn't normally have a name, but I'm going to write that as 2 pi over the period. Now, if the period is 2 pi, it's going to be just 2 pi over 2 pi, which is going to give you 1. You still need to figure out the value for this. Then the C value, depending on which equation you use, whether it be sine or cosine, that is going to change. So I'm going to kind of table that for the time being. And then my D value is going to be the minimum plus the A value. So the minimum, which is -2, plus 3, which gives me 1. Now, just to kind of take a look at what that means, in this problem, it means that this is the midline, or also known as the equilibrium. So if I draw that line in there, I can see that if I go 3 units up or 3 units down, I end up getting to either the max or the min. So the amplitude acts as that distance between the midline to the top or midline to the bottom, right? It kind of helps you along. Now, I'm going to write down my equations. I'm going to use this point right here, my lowest one, A. I'm going to write my cosine. Now, cosine either starts at a low point or a high point, while sine starts at the equilibrium spot. So I'll show you what I mean for both of these. So I'm going to write y equals, so since A, technically I'm going to use A as my starting point. Since A starts at the lowest point and goes up, that would give us a negative cosine. Now, if it started at a high point, then it would be a positive cosine. So I start with negative my A value, 3, cosine of my B value, which is 1. So I can write that as 1x. There's no C value because I started actually on the y-axis. So then, and then plus 1. Now, if I were to be using, let's say, sine, so I'm using this right here, I'm going to use B. So I'll mark that as B. Y is equal to, now if sine goes up first, right, starts at the midline and goes up, then I would say that it is a positive sign. Now you don't technically need to write a positive, but I like to just kind of as a reminder that I'm checking whether it is going to be positive or negative. I would write this as sine 1b, so I'm just going to write this as x, right? But then since it is moved over units away from the y-axis, it moved over how many? In this case, it's going to be pi over 2. So I'm going to write this as minus pi over 2 because it's moving right, and then plus 1. Now, there are multiple ways of writing these equations. Those are just 2 examples that you could use. Okay, so I'm going to make this one go rather quickly. So my max, in this case, is going to be -1. My minimum is going to be -5. My period, on the other hand, is going to be something kind of odd. So I'm going to be using, let's say, this point and this point. Well, it looks like it's actually just going to be 2. Okay, it looks like that our midline is actually going to be a -3, but I want to make sure I do the math to go along with it. So max minus the min, so -1 minus -5 divided by 2. So that's actually going to give us 4. 4 divided by 2, which is 2. My b value is going to be 2 pi over the period, which in this case is going to be 2. So I get pi. C, right, depends on whether I'm using sine or cosine. I like to use the point that is on the y-axis, so I don't actually have to use a value for my phase shift or my C value. So if I use sine, I don't necessarily need to have it moved over. And then my D value, which is the minimum, which is -1, it should be at -3 plus 2, which is going to give me 1. Ooh, that's not right. So let's see, where did I make a mistake? Yep, I made my minimum needs to be -5. So -5 plus 2, which gives me -3. Okay, from here, so that means that we're talking about this line right here. That's exactly where the sign is going to start. So I'm going to write this as y is equal to my a value, 2. And since it's going up, I can write a positive sign. So sine of 2, or 2 sine, parentheses. Since my b value is pi, I'm going to write this as pi x. There's no c value, so I don't need to do plus or minus 0. And then -3. And that would be my equation. All right, next I will be moving on to the calculator section of this review packet. Thank you again for watching. If you have any comments, please comment down below. And thanks for watching.